Hi, and welcome to this video about Unit 2, Concept 6, which is translating equations. This is a sneak preview of a concept we'll study later, Concept 8. So please flip right now to page 7 in your packet, where you can fill in these notes. We're going to use an annotation strategy in this class called cubes. So when we say annotate with cubes, what we mean is you should circle all quantities, all numbers. You should underline the question, box in keywords, vocabulary, action, units, then expand on what you know, squiggle any rounding, set up a key, and solve. These things may seem obvious, and maybe at this point these questions are easy enough that you feel like you don't need to use annotation. However, as we progress in the course, there will be more complicated material, and you're going to want to have this strategy. So it's important that you practice it now so that when you get to those more complicated problems, you're ready to use it. So some vocabulary to start us off, and some of this you may have already known, but there are some certain keywords that should remind us of the operations in mathematics. So for addition, the word sum is the result of addition. You also may hear words like increased or more than that tell us to add. For subtraction, the word difference is the result of a subtraction problem. You also might hear decreased or less than. Now, less than has a really special rule. We switch the order. Let's take a second and talk about what that means. So if Brittany has 10 pencils and Andy has 4 pencils less than Brittany, does Andy have? Well, let's break that down again. So whatever Andy has is 10 less than Brittany. So Brittany has 10 and Andy has 4 less than that. So whatever Andy has is 10 minus 4, which is 6. You may have gotten this answer without showing it as an equation, but we do this to make an important point, that when we say less than, notice that normally we would have translated 4 less than what Brittany had, which is 10, but this would give us negative 6, which does not make sense. It does not work out here. So when we have less than, we switch the order so that we get 10 minus 4 in this case. We're going to see more examples like that. The Regents loves to use that phrase because they know that it can be tricky. So please remember, when we have less than, there's a special rule, switch it. Certain words that you'll hear are product, times, twice, and of, especially with fractions or percent. That can often tell us to multiply. For division, this word quotient is kind of weird. It doesn't really sound the way you'd expect it. Again, the way this is pronounced is quotient. And I'm actually noticing a quick typo. So increased by would not be an example for division, but ratio definitely is. Please pause here if you haven't gotten these notes already. Finally, we have 2 other phrases and words that we see in translation. When we hear a number, that means an unknown, which we use a variable to represent. And the word is in math means equals. Again, make sure you have all these notes written down, then press play to continue. Moving down in your packet, we're skipping over some to it. Please note that equations are things that have equal signs. They have a same root to them, right? Equal and equation. Expressions do not have equal signs. So when we look at this first example, x plus 5, this is an expression because there is no equal sign. Press pause now to answer these questions, then press play to check. Notice that we have 3 equations and 2 more expressions. If you're not sure why, please refer back to your notes or write down a question for us. So in this practice, which is a little bit above in the packet you're looking at, we're asked to write an algebraic expression. So please notice that we will not have any equal signs here since there are expressions that we're being asked to write. I'm going to use that annotation strategy, cubes, to help break down these problems. So first I look to circle any quantities or numbers. So here I see the number 2 increased by a number. We don't know what that number is, but it is a number, so I'm circling it. The question we're asked is to write an algebraic expression. That's going to be the same for 1, 2, 3, and 4. Some keywords are increased by in this expression. And if I'm going to expand on what I know that that means plus. I also know that a number means a variable, so I'm going to use x to represent it. I also know that this is just another way of writing the number 2. So now I've actually finished what they've asked us to do, writing an algebraic expression. 2 plus x represents 2 increased by a number. Let's try number 2 together. 5 is a quantity, 3 is a quantity, so I'm circling, and a number is an unknown, so I'm circling that as well. I can start expanding on what I know, knowing that 5 is a 5, 3 is 3, and a number is a variable. I see some math action words like times, which I know means to multiply, and I see less than. Now when I hear less than, these little alarm bells start going off in my head. I know that it means subtract, but there's also that special rule for less than. So don't forget, when we have less than, we have to switch the order. So we also had multiplication over here, which I'll show with a dot. But please remember that if we have a variable next to a number, that also indicates multiplication. So I'm going to put these two together as 3x. And since it's 5 less than 3 times a number, it's 3x minus 5. Okay, again, we switched the order because it said less than. And we just decided that we did not need to include the multiplication there. Since it's written next to each other, we know that this is multiplication. Take a second and try 3 and 4 on your own, then press play to check. So I've started doing number 3, but I've paused here to remind us that the word and tells us where the operation goes. So since it said the quotient, I knew that was about dividing. N tells us where the operation will go. So our final answer is 3 divided by x. You could have written it this way, but notice that in high school, most often you'll see division represented as a fraction. Either one is correct, but we would like to see you getting used to using fractions for division. In number 4, we have that tricky word less than again, which reminds us that we're going to have to switch something. It also said the product, which means to multiply, of 3 and a number. N tells us where that operation is going to go, and a number is an unknown. So we have 3x minus 8 as our answer. The next practice area is a little bit different because now we're translating to an algebraic equation and they would like us to solve. So when we annotate, it's important to underline the question, especially as we get into more complex problems, because sometimes it'll ask us to do more than one thing. In this example, they tell us that a number decreased by 26 is 18. Remember that word is tells us equals. So we have a number, an unknown, decreased by 26 is, and this is a correct translation of the problem. So we've done the first part, but we also now must solve. They want us to find the number. So using what you've learned about solving equations, this one's a pretty straightforward one. We're going to use inverse operations to eliminate that constant. And we get that x equals 44. Please complete problems numbers 6 through 8 in your notes and be ready to ask any questions you have when you come into class tomorrow.